Okay, this video is going to explain the answers to the multiple choice quiz from class. So I'm going to work them out, and you need to work them out on separate paper and bring them in. This first question is an arc length, and this one's a parametric because we have x and y separate. So the parametric arc length formula, we need to take the derivative of each one of these, and we need to square it and put it under the square root symbol. So if we're going from 2 to 3, each of these is a product rule, e to the t cosine t and e to the t sine t. So I'm going to do the derivative with the product rule, and then I'm going to square the result. Okay, so first times the derivative of the second for e to the t cosine t. Derivative of cosine is negative sine. And then that's first times the derivative of the second plus second times the derivative of the first. The derivative of e is e, so plus e to the t cosine t. That needs to be squared. And the second one is similar. First times derivative of the second. Derivative of sine is cosine. Second times derivative of the first. I should have put that e to the t first, but you get the idea. And that's squared. And that's dt. And this is from 2 to 3. Now this looks pretty bad without a calculator, but it gets a whole lot better. When you multiply this out, you would get this term squared, which is going to be e to the 2t sine squared t. Then you're going to get minus 2 times this. So that's going to be, let's see, that's going to be 2 e to the t sine t e to the t cosine t. Well, the middle term from over here is going to be minus 2 e to the t cosine. You know, they're going to be opposite and equal, so those are going to wipe out. And what we end up with is, actually, though, those are going to, let's see what those are going to do. Yeah, those are going to wipe out. We're going to get e to the 2t sine squared t, e to the 2t cosine squared t. And then this second bunch is going to give us the exact same result because the middles of those are equal and opposite. They're all going to wipe out. So that got rid of a lot of it. What's going to happen next is we're going to group our like terms together. We're going to have 2 e to the 2t sine squared t and 2 e to the 2t cosine squared t. Then if you were to factor out 2e to the 2t, you'd be left with sine squared plus cosine squared. And sine squared plus cosine squared is 1. So basically what we can do is factor out 2e to the 2t and be left with 1, because sine squared plus cosine squared is what would be left over. And I lost my square root. So if I square root that, I'm going to separate the square root of 2 and pull it out, and then take the square root of e to the 2t, which is e to the t. And finally, the integral of e to the t is e to the t. I need to plug in 3 and 2. So I've got a square root of 2, plug in 3, plug in 2. My answer turns out to be B. All right, so I quickly went through that algebra. Just make sure you understand that where, you know, if you multiplied everything out, I kind of left a few steps out, but the important parts are there. All right, so on number 2, we're going to choose the integral that is the volume by rotating this yellow region around the x-axis. All right, so this is washers. All right, we're going from 0 to 2, pi on the outside. We've got big radius and little radius, each squared. My big radius is the upper function. My little radius is the lower function, all dx. So that one's pretty straightforward. That one should be C. All right, if you don't have a picture and you need it, just plug in a couple points. You know, you just have to, I already had the graph drawn, but plug 0, 1, and 2 into your parabola, and you can see where that shape meets the line. you'd be able to do that. You know, it's not, you're not going to have to do any ridiculous graphs without a calculator, but that's one you should. All right, so we have y equals x squared, y equals 4. That's the blue region, and we want to spin it around y equals -1. All right, so this one, we're going to be using washers. The thing about multiple choice questions, it might not look the way you would make it look if you were doing it without multiple choice. But you might have to manipulate your answer to make it look that way. I'm doing washers. So this is pi. And I would go from -2 to 2. Or because of the symmetry and what they did, they went from 0 to 2 and doubled it. So that puts a 2 pi out front, which makes it look like shells. But you just have to realize, you know, our basis is pi r squared. But if we're doubling it, that could be a 2 pi. So keep that in mind. So then we just need a big radius and a little radius. This is all going to be dx. The big radius is 4. Excuse me, the big radius is 5. And the little radius is this distance here, which is the function plus 1. So that's x squared plus 1. So it's always 1 more than the function itself. Now, because we have parentheses squared, we're going to have to square that. And if you were to write it out twice and FOIL it, you'd get x to the 4th plus 2 x squared plus 1. And all that is subtracted because of the minus sign in the front. And so you combine the 24 and the -1, excuse me, 25 minus 1. You've got -2x, x to the 4th. And that's how we end up at D. All right, so don't be thinking washers and ignore any answer that has 2 pi in the front. All right, arc length, natural log cosine. All right, this one's kind of complicated to do by hand. It's doable, but it's tough. All right, so we're going to go pi over 4, pi over 3, and we're going to integrate square root of 1 plus the function, or the derivative of the function squared. All right, so the derivative of natural log of cosine is negative sine x over cosine x. That's du over u. All right, so, and then because our arc length formula, that is squared. So that kind of breaks down to square root of 1 plus tangent squared. Okay, 1 plus tangent squared under a square root, that's nothing we can really deal with, but 1 plus tangent squared is secant squared, and then we're down to just secant. All right, so that's kind of a lot to remember right away, and I'm switching between x and theta, forgive me. We're down to just the integral of secant, and that by itself is tough enough. Then you have to remember the integral of secant. The integral of secant is natural log, absolute value, secant plus tangent. I know it looks familiar. Pi over 3 and pi over 4. Then you have to remember all your unit squared values. So I'm going to let you plug pi over 3 and pi over 4 into that. It turns out our answer should be A. I'm going to let you fill in the gap between there and there. I gave you all the important parts. And we'll skip on to 5. All right, this is the base of a region. The cross sections perpendicular to the x-axis are squares, which is about the easiest geometric formula you can get. Remember, in this case, we integrate the area. That's what you're going to remember. Vertical rectangle over here means dx, which means we're going from 0 to 1. The area of a square is side length squared, and the side length is e to the negative x. Don't do pi. There's nothing circular about this. Don't assume pi is always a part of it. So if we integrate e to the negative 2x dx, that is the same as that. We need there to be a du. All right, u is negative 2x. du is negative 2 dx. We need a negative 2 here, negative 1/2 here. So our answer, once you have that, your answer is just the same as the original. Okay, so remember, the integral of e to the u is e to the u as long as du is there. E to the negative 2x is much more understandable to me as e to the 2x on the bottom. Okay. Plug in 1, what do you get? You get 1 over e squared. Plug in 0, you get 1 over e to the 0. Remember, 1 over to the e to the 0 is 1 over 1, which is 1. And if you distribute this negative sign, that's going to give us e. So it didn't look exactly how I ended up, but you just have to figure out which one is going to make it work. All right. Try to move a little quickly here. Find the volume of the solid. The region bounded by the graphs is rotated around, in this case, y equals 4. X squared, y equals 4. The purple region rotated around y equals 4. All right, so this one takes some solving after you get your integral set up. Let's get the integral set up. All right, this is going to be disk method because the region borders the axis of revolution the whole time. Again, you could double it. That lets you plug in 0. All right, you could go from negative 2 to 2, or you could go from 0 to 2 and double it. And let's see, our radius, this distance is 4. This distance is the function x squared, so our radius is 4 minus x squared. All right, so if you multiply all of that out, you're going to have to FOIL it out, and you're going to have to sub in your, let me put a 2 there because I went from 0 to 2 instead of negative 2 to 2. So you're going to have to FOIL that out, integrate it, plug in the 2 and the 0, and then distribute the 2 pi. And to make this video a little shorter, I'm going to save you the having to listen to it. Do that on your paper. It'll take 3 or 4 minutes, but do that and make it equal 512 pi over 15. Okay, number 7, the volume when we rotate this shape around the y-axis. All right, so you have options. I would do shells here. We'll take this shape, rotate it around the y-axis to make shells. 2 pi, 0 to 2. Radius times height is what we think of when we're doing shells. The radius of each shell is just the distance from the axis over to the graph, just x. Height, it's not the function, it's 4 minus the function, just like it was in the previous problem. There's no squaring it, it's just radius times height, dx. So in this case, you're going to have to distribute the x, integrate, plug in 2 and 0, distribute the 2 pi. Again, I'll save you the listening to me talk about the algebra. You have to do the algebra, but you can do that on your own. The integration and the algebra. And we can skip down to 8. Now 8 is in terms of, it's our functions turned sideways. So that makes it a little more, this picture, I'm ahead of myself. That one goes there. The parabola x squared minus 3 and the line y equals 1. X squared minus 3 looks something like that. Down here, move down 3. Y equals 1 is here. So there's the shape. And if we want to, we're just finding the area in this case. So what you need to know is where do those intersect. And you can find with a little checking that those are going to intersect here and here, which should be at, let's see, that should be at minus 2 and 2, I believe. Yeah, if we plug in minus 2 and 2 into x, we get 1 for both. So again, if you want to double it, you can go from 0 to 2. Let me get out here to the side. My graph's in the wrong place. So I'm going to go 0 to 2, double it because I'm just doing half of the graph. And then my integrand is 1 minus the function. All right, so don't overthink the area ones. You're just going to integrate top function minus bottom function. On number 9, I'm going to integrate top minus bottom, but think of it going to the side. I'm going to integrate right minus left. I'm going to, by just plugging in some points, I tell my intersections are at -2 and at 1. So everything is switching over to y land now. I'm going to integrate from -2 up to 1. I'm going to do the rightmost function solved for y, which would be 2 minus y. And I'm going to subtract from that the other function, which is y squared, already in terms of y dy. So another one where you're going to have to do the integral. You don't really have to do any algebra first. Just integrate each part, plug in your 1 and your -2, and that one should end up being 9/2 d. So those last few, I left the work for you. I got the setups, but you're going to have to do the work yourselves for the bonus. Okay, 10, 11, 12. These should go quickly. Which of the following series converges? We have a bunch of basically p series. We have the harmonic that diverges. This is into the 1, into the half, into the third. Those are all out because those are all p series on the wrong side. 1 over 10n minus 1, this essentially behaves like 1 over n. The 10 and the -1 don't mean anything. E is our answer because it's essentially 1 over n squared. And that's a p series with p equals 2, and that's good. 11 is a bunch of series. They're all alternating. Remember, in alternating series, the only thing that has to be true is the terms have to be getting smaller for it to converge. That means A, C, E, and B, these are all getting smaller because the denominators are all getting bigger. D is the only one where the terms are getting bigger. That's not even allowed into our bubble of possible convergence. That's a nth term test done, diverges. And finally on 12, this is geometric. We plug in 1, we get 2/3. We plug in 2, we get 2/3 squared, which is 4/9, 8/27. All right, this is geometric. First term 2/3. Ratio also 2/3. So that's 2/3 over 1/3, which is 2/3 times 3, which is 2. All right, so those last ones move pretty quickly, especially when you compare them to these volumes and areas above. All right, so that's them at least set up. If you need to see some of the steps later on, we can do that in class, but I want to cut this off before it goes too long. So you need to finish these up, work them out all on separate paper, and bring it in for some bonus points. All right, so we're well underway in our AP review. We're all getting 5s. Work hard. See you in class. Out.